Okay, welcome to CSC की दुनिया. Now today's lecture is on Floyd Warshall. Floyd Warshall means all pair shortest path, in which we are going to find shortest path between each and every node. Suppose first node is 1 and the other destination nodes are 2, 3, 4, 5. So we have to find the shortest path between 1 to 2, 1 to 3, 1 to 4, 1 to 5. Same with this, we have to find the distance between 2 to 1, 3 to 1, 4 to 1 and 5 to 1. It means we have to find the shortest path between each and every node. So let's start with to find the shortest path. Now the first we have to do that to create the distance adjacency matrix. Now what the adjacency matrix, in which we are taking the distances from direct connectivity. Suppose the size of this matrix is total number of maximum nodes. Maximum nodes are 5. So we are creating the matrix 5 cross 5. Now these are the source node and these are the destination nodes, in which we are going to create the adjacency matrix. So we are taking 1 to 1 is always 0, 1 to 2. 1 to 2 is 3 because there is a direct path from 1 to 2. So 1 to 2 is 3, 1 to 3 is 8, 1 to 4. There is no direct path from 1 to 4, so we take infinity. And 1 to 5 is, there is a direct path from between 1 to 5 is -4. Same with this, we are taking the source node as 2. Now we are taking the distances from source node to every node. Now let's see, is there any path from 2 to 1? No. So we take this as infinity. Now 2 to 2 is 0. Same source and same destination node weight is 0. Now 2 to 3 is infinity because there is no direct path from 2 to 3. Now 2 to 4 is 1. 2 to 5 is 7. Here it is. And this rules follows to each and every node, and we create a distance matrix, adjacency matrix for this graph. Now we take this pi matrix. Pi matrix represents in which distance matrix we are going to update the value from source node to destination node. Pi 0 represents the value at this source node. Suppose this value represents source node 1. 1 to 2 is 3. And in which distance matrix? In which source node? 1. So we represent this node as 1. Same here it is. These values represents source node 1. So basically in pi 0 matrix, we represent that source node in which the value is represented. Means there is a direct path from node 1 to node 2. Now we are going to find the matrices, find the values from node 1. Now we are creating the distance matrix 1. Now there is a question, how many matrices we have to calculate. So total number of maximum nodes. Suppose there are 5 nodes, so we have to calculate the distance matrices 1, 2, 3, 4, 5 with pi 5s. Okay. Now we are going to calculate D1. D1 takes just previous updated matrix. For D1, there is a D0 updated matrix. Now the graph is clear. Now D1, what we are going to do? We have to select first row and first column in just updated previous matrix. For D1, we have to take D0, in which we select first row, first column, because we are finding the value of distance matrix 1. Now just copy this row and column in distance matrix 1. It means there is no updation from matrix from source node 1. Now just we are going to copy the values from distance matrix 0, and what's the starting of distance matrix 1 is 0, 3, 8, infinity, -4. Same, copy the column values 0, infinity, infinity, 2, infinity. Clear? Now what we'll do after this, we'll see where is the infinity in these selected row and columns, and copy that particular row and column in which cell, in which the selected cell we have infinities. Where we have infinity? Here it is, here it is, here it is, here it is. Now what we are going to do? We copied the row and columns in the from the updated previous distance matrix, same as it is. Now we are going to copy the rows infinity 0, infinity 1, 7. Next is infinity, 4, 0, infinity, infinity. Next is last row, infinity, 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 6, 0. Clear? Now we have to copy fourth column, because there is an infinity from 1 to 4 is 0 to 1, 4 to 4 is 0. Now you can see that there is some cells which are vacant. Now how to calculate these values? See, in the previous matrix we find the cell on which we are going to update, या फिर हम कह सकते हैं कि हमें किस सेल की वैल्यू वेकेंट मिली है, उस सेल के रिस्पेक्ट में हम जस्ट प्रीवियस वाले पोजीशन पे आएंगे और उसके रिस्पेक्ट में देखेंगे कि क्या क्या वैल्यूज हैं आपकी सिलेक्टेड रो एंड कॉलम में. क्लियर? सिलेक्टेड रो और कॉलम में आपकी क्या वैल्यूज है? 3 + 2 दैट इज 5, एंड अगेन आफ्टर दैट वी चेक दिस अपडेटेड वैल्यू विद द प्रीवियस वन. Previous value is infinity and the new updated value is 2 + 3 is 5. 5 is less than infinity. If the new updated added value is less than the existing value, then we update the values, otherwise we don't update the value because we are going to find the shortest path. So there is 5 is less than infinity, so we update this cell value as 5. The previous value is infinity. It means there is no path from 4 to 2. But in this matrix, there is a path from 4 to 2 via 1. We can see that 4 to 2 via 1. There is a path. Initially, we don't have direct path. So we write 4 to 2 is infinity. But at distance matrix 1, we find the path from 4 to 2 via 1. The distance matrix is 3 + 2, 5. And we update this cell as 1 because we update this value with the help of source node 1 in this cell. Clear? Same with this, we are going to find this another value. This one, the same concept. Respective column 2 and respective row is 8. 8 + 2 is 10. 10 is not less than -5. So we are not going to update this value minus to 10. The value from 4 to 3 is -5. So we are not going to change this value. Now the last value 4 to 5. 4 to 5 is infinity initially. But we can see via node 1 can we traverse from node 4 to 5. Let's see. We have to find the value of this cell. We check respective column value is 2 and respective row value is -4. The value is -2. -2 is less than infinity. So we update this value as -2 and we update this cell as -1. And rest of the values will be same as the pi 0. Same concept will be again for finding the values at distance matrix 2, 3, 4 and 5. The final answer is this. In distance matrix 5, we find the shortest value, shortest path between each and every node. There are some nodes at some time A will be source node and all other the destination node. But in this Floyd Warshall algorithm, we can also find the shortest path between 2 to 1, 2 to 3, 2 to 4 and 2 to 5 via intermediate nodes. Thank you.
जिसने सब्सक्राइब नहीं किया है वो प्लीज सब्सक्राइब कर दे.